Okay, we're now going to talk about our last primitive data type, which is the Boolean. So Boolean is a very useful data type. It represents a true or false value, and it's saved in memory as a single bit. Okay, because a bit is a binary digit. It's either a 0 or a 1, and a Boolean is the same way. It's either a true or a false. It can only have one of those two values. It's like a light switch. It's either on or off. And for the moment, this might not be all that useful to us, but as we learn more complicated programming paradigms like if and if else, we're going to be using these Boolean values all the time to control how our program runs and how our programs make decisions. So those are our three primitive data types, the int, the double, and the Boolean. So now I want to revisit a concept from the beginning of this lesson, which is domain. All right, domain, remember, is the range of possible values for a particular data type. So I'm going to use an int as our example, and the int has possible values that range from negative 2,147,483,648 to 2,147,483,647. That's all the possible integer values you can have. Now you might be asking, why can't we store why can't we store infinite values? Why do we have to put a cap on it? Well, you have to remember that computers have a limited amount of memory. And so the programmers who wrote Java said, you know what? Let's just block off a certain number of bits for integers because most programs are not going to need numbers larger than these. And if you need a number that's larger than this, there are data types that you can use that are more rare, but you can use them to get larger numbers or smaller numbers. So we can actually access these values, and we can access them by using the word capital I integer dot all caps min underscore value or unmax underscore value. And these are called constants because they're created using one keyword called final. Final is a keyword that basically allows you to create variables that are never going to change. All right, and we don't want min value or max value to ever change. We want those to stay the same. So here as an example, if you wanted to, say, enforce a smaller maximum or minimum, you could create your own final called max and set it to 1,000. Now that's not going to affect how the values are stored in the program, but you might write your code so that it obeys this as a rule. So those are our primitive data types, and I wanted to go over quickly the differences between primitive and reference data types. For now, we don't have that many differences, but we're going to add to this as the class goes on. So our primitives, we have int, double, and Boolean, and our reference data types that you've seen, string you've worked with a lot, integer, you just briefly saw it when we talked about max and min value, and then later you'll have custom classes you write yourself. Now I did want to note that sometimes reference data types will be referred to as class data types. This is because those two vocabulary words are used somewhat interchangeably. In the literature, they mean the same thing, but because you write so many of your custom classes, your own class data types, sometimes it's just easier to refer to them as class data types. So the thing to remember about primitives is that when you create a primitive value, the variable that you are using to store that information is holding the actual value. When you create a reference data type, the variable you create holds a reference to a memory location where that information or that string is stored. This is the reason that we call them reference data types, because the variable is actually holding a reference to a memory location instead of the actual value. And what this means is that any reference data type is stored as a memory address, and then Java can basically allocate the space for different sizes, different types of reference types as the program is created and as you create more custom data types. The one other difference I wanted to mention, ints, doubles, and booleans all start with a lowercase letter. String, integer, and your custom classes will start with an uppercase letter. This is not necessarily a requirement, but it is a coding convention that you should follow so that you and other programmers can work together and always know if you're dealing with a primitive or a reference data type. One thing to consider as you're learning about different data types is how much memory they're actually taking up in your computer storage. So here we have a ranking of different data types from smallest to largest in terms of how much data they take up in memory. The smallest is going to be your Boolean, which is really just a single 0 or 1 for true or false. Then you have your int, which is just going to be whole numbers. That's pretty small, doesn't take up too much memory. Then doubles take a little more memory because they have to remember the whole number part and also the decimal component. And then you have your string. Now, a string is not a primitive data type, and so it does take up more memory. It ends up needing to remember not only the letters, but also other information that goes along with class data types. And then we'll have other classes that we learn later that take up even more memory. So this is going to become important not only when you're thinking about the efficiency of your programs, but also as we start converting or we learn to convert between data types, understanding how large and when you're converting from a larger to a smaller or smaller to larger data type is going to impact how those conversions happen. So it's useful to keep this in mind as you're working with different data types. So now let's play around with Booleans a little bit in a coding demo.